Hi everyone, thank you so much for joining me for the first data science and ML session. I'll be taking you through how you can start your journey with Python. As you know, we're doing this track, we're focusing on data science and machine learning, and we'll do at the end a bit of AI. So to be able to do all these things with data science, to wrangle the data, you probably need to have knowledge in one of the languages that executes this. So today we'll be going through one of my favorite languages, that is Python. And before I kickstart the presentation, maybe just to mention a few things. First, this presentation is recorded, so in case you want to follow up with it at a later stage, feel free to do so. You can just come back to the same link and check it out. Second, the comment section is open, so in case you have any questions, feel free to drop them on the chat and I'll be here to answer them. And lastly, yeah, I think we'll get started with that. Before I continue and dive into the Python and everything, you might be wondering, okay, who's this person? So I'm Bethany Jepchumba, an academic cloud advocate at Microsoft. I am also the lead of the DS and ML track. In this journey, I'll be with you throughout the entire session. So be free to ask me any questions. And then I also work at Microsoft with the rest of the team. And you can find me on any social media platform using at Bethany Jep. Okay, so what will we be tackling today? Let me head over to my slides. And we'll be going through how you can get started with Python, diving deep into something I love, which is just creating a small calculator to calculate someone's BMI. You'll learn about operations and stuff. But before we get into now the big picture, like learning about Python and everything, there are some prerequisites that you need to have. So the first one is having Python installed in your machine. So probably I'll just do a few of this. I'll do a few of this on my browser so that you can be able to see where the links are going. So on python.org, you'll find downloads and then go ahead and install. Download Python 3.10.5. This is very important because without it, you technically can't run any Python code on your browser or your local machine. Second is installing Visual Studio Code. This is the IDE we'll be using. An IDE is basically a platform whereby you can write code in your local device, and it's very easy to use Visual Studio Code because one, you can be able to see the syntax clearly, see the errors, and two, it's easy to sync up with everything else. So go ahead to code.visualstudio. Oh, and I'll be looking on my right because that's where my desktop is. So I am so sorry if I may not be looking at the screen the entire time. So code.visualstudio.com, and then from there /download. From there you can download whichever is for your device. So if you're using Windows, this is the right one for you. If you're using Linux, these are the options you have, and if you're using Mac, these are also the options you have. After you've installed all this, the next step is going ahead and launch your Visual Studio Code. And one of the extensions that we'll be using is number one, the Python extension. This will automatically be installed for you once you download the Python in your local machine. Or the other option is go ahead, search for Python under the extensions and install it. The other one, very key, is Jupyter Notebook. So go ahead, look for Jupyter, also install. These are two very important. These are two very important extensions you'll need. And lastly is Git. So of course, you'll need to showcase your projects once you're done. You'll need to show the world that, hey, I've been working on all this, and yeah, I need you to see that I've been working on this. So what you do is download Git, which will help you link up with GitHub. And of course, these are also like the different varieties of Git. Number one, it will also integrate directly with Visual Studio Code so you can be able to use it. And second, you also will be able to, one, save your code to the cloud. Two, you'll also be able to check your history. So how did you, so questions like who edited your code, what did you do at each stage, so what did you do today, what did you cover tomorrow, and so on. So these are the very important prerequisites that you should have at the moment, and we'll dive into git and GitHub commands at the end once we're done with our codes locally. But yeah, be sure to do all that. And then the next thing is just an overview of what we'll be covering. First, we'll be figuring out how to manage our inputs and outputs. We'll create variables. We'll see the differences between the various data types and how to convert different things into different data types. And lastly, we'll do a bit of conditions. And of course, at the end, you'll be able to calculate BMI. So I've mentioned the word BMI a couple of times. So what exactly is it? BMI stands for uh, the mass index, the body mass index, which is like determines whether you're overweight, you're underweight, you're obese. And of course, we wouldn't be able to create a fully fledged BMI system because that will mean having inputs that we, at the end of this lesson, we wouldn't have covered. But we'll just create a simple one that helps you understand which class you fall under. So whether you're underweight, overweight, obese, or you're just perfect, you're healthy. So in this, you can go ahead and also experiment on your own while I type the code. But otherwise, yeah, let's get our hands dirty. So heading over to Visual Studio Code. A second. I hope you can see my screen. Okay, yeah, we are on Visual Studio Code. And the first thing we might need to do is create a new file. So I'll go over to terminal. And this is my terminal, just helps you write commands on your application, on your Visual Studio Code. And then here I'll do a code. I'll just go to my desktop, so cd desktop. And then once at desktop, I create a new file that will be MD, and then the file name. So let me call it BMI index or BMI calculator. Ooh. Oh, sorry, I've used the wrong command. Let me see. Sorry for that. I'm supposed to create the directory first. So that is BMI calculator. Oh, that's interesting. Object not found. Directory a second. Ooh. Let me just create it locally. So let me just open a new folder, go to my desktop, create a new folder. Ooh, sorry for that. New and then folder, BMI index, and then select the folder, and it opens up on Visual Studio Code. So you don't have to rely on the command line. I'm sorry for that though. I'll get the commands after the session to figure out where exactly I went wrong. But then what we want to do is we want to create our first Python notebook. So we can call it BMI.ipy Python notebook. And voila, our first notebook was launched. So a notebook is just as it is, it's a notebook. And it consists of different cells. Either the cells can be either in code or markdown. So code means you can write your Python codes there. Markdown means you can write and type text. And then run all helps you to run the different cells. but you can also click here to run the different cells. You can just press anywhere here, create a new code, and then these are the different commands of like whether you want to run this by line, whether you want to execute the above cells, execute the one below, and so on. So let's start with something simple, something like, okay, the first thing you normally do when you're beginning with a new language is something like hello world. So I'll go and type. So this is what is called a comment. A comment is an non-executable piece of code. So with a comment, it's just like writing what this code does. So this one prints, this one will give an output of hello world in Python. So that's what we want to do. And to give an output in Python is one of the simplest things. You just do print, and you see the benefits of an IDE, the fact that it actually gives you like the prompts of like, you can, what you're probably trying to type print, but you might also be trying to type property and so on. So this is one of the benefits of using an IDE. So print, and then the two brackets. Inside, you now dictate what exactly you want to print. And I want to print hello world. So hello world is a data type called string. We'll cover that in the next part. And as a data type named string, you have to use the quotation marks. So under quotation, you write hello world, and then control enter or run. And from there, you can see hello world is printed. If you wanted to like run this and create another new cell instantaneously, just use shift and then enter. It runs as it creates for you a new cell. So of course, that's the first thing we've printed, hello world. And then the next thing is trying to see, okay, what else can we do with Python? So let me give you another basic example. So probably doing sum of different values. You want to add 1 plus 1. So sum 1 plus 1, if I just write 1 plus 1 here and control enter, it will give me 2. But there's something called variables. Variables help you store the value of something. So I want to go ahead and do this, probably find the sum first, and then find the multiplication of the sum. So I'll create a new variable called sum. A variable is will just store what sum is. So sum probably of 23, which is 23 plus 12. Yeah. And then from there, probably want to multiply the sum. So I'll do the multiplication, which is multiplication, then define it as sum multiplied by 2. If I run this cell, nothing will happen because I've not said, okay, once we get the multiplication, this is what you do next. So what I can do is probably do something like a print, and then in the brackets, I do print the multiplication. I do control control enter, and you can see the value there, 70. So if you do this with your calculator, it will give you the same value. But then the lesson I'm trying to teach here is sum store value. So let's see, for example, you don't want to store numbers. You want to store something like a name. So I'll do name is equals to, so my name, Bethany. And then country probably is equals to, I'm from Kenya. And then I print, but then I want to print something like Bethany comes from Kenya. So I'll do name plus comes. So Bethany comes from, and then add another one and write country. And from there, if I run, it will tell me Bethany comes from Kenya. So with variables, you can also store things like names and everything else. So it's not limited to just numbers. And I feel like I've written a lot of numbers and values, and you're wondering, okay, are there like different data types in Python? Of course, yes. So we have 4 main data types. One is the integers. Integers are basically numbers. The other one is a float. Float are things like so let's do an example. So the data type we've said we have integers, we have floats, we have strings, and then we have booleans. So for example, we're talking about BMI. BMI requires you to calculate the height of someone. It requires you to input the height, the weight, and then define whether someone is overweight or not, overweight, and then lastly, the results. So for height, it might be something like 1.34, because the height we use is in meters, so probably might be 134 centimeters tall. And then the weight is in kilograms, so probably you might be about 50 kgs. And then overweight, true or false, probably may not be overweight or maybe overweight. So depending on now the answers. And then the last thing is the results. So the results is you want someone to know whether they're overweight or not. So you'll do you are overweight, very overweight. And that's it. So these are the different data types. The first one is a float. A float is basically decimals, so values that have decimals in them. Weight is just a number without any decimals. This is Boolean. Boolean is either something is true or false. Are you overweight? True. Are you not overweight? False. And then this is a string. A string is now text data that you write. So if you want to tell someone the same thing I did here, if I want to say I come from Kenya, these are all strings. If I want to do calculations, these are almost all integers. If I had something like 0.5 here, I will change it to a float value. Okay, that's it about types. So how do you determine like what is the type of something? So you just type literally just type and then add something like height and then figure out what is height. Oh, sorry. Oh, name height is not defined. Oh no, I've not run this cell, sorry. So if I run again, you can see it's a float. If I change it to something like weight, it will tell me this is an integer. If I change it to something like overweight, if I add overweight, that's a boolean, and so on and so forth. So that's how you determine the different data types in Python. You'll deal a lot with strings and integers and floats when you work, and even booleans when you're working with data. So probably someone just replied and said, yes, I am overweight. No, I am not overweight. Those are boolean types. So it's either true or false. Someone said, hey, my height is 134 meters, so you have to convert it to something like centimeters or something. 134 centimeters, so you have to convert it to meters and so on. So that's it about data types. The next part you're tackling is assignment operators. Before I continue, let me check if there's anyone who's asked any question. So let's see, no one has asked any questions. So I'll just continue and go ahead and continue. So we've done a bit of types, we've done a bit of variables. So the next thing is operators. So we have two types of operators. One, we have arithmetic operators, and secondly, we have arithmetic operators, and secondly, we have the assignment operators. Arithmetic operators are those that you use in maths. So addition, subtraction, division, and multiplication. And then assignment operators is now when you're saying something like, so Bethany is 2 years old, so Bethany is equals to 2, but then after 1 year she'll increase by 1, so Bethany increases her year every time, or probably decreases her weight over time. Or you can do something else like, I have 10 cupcakes and 2 of my kids come every day to take cupcakes. So every day they come, the cupcakes are divided by 2, they reduce, and so on. So that's the thing with the operators. So let me go and try doing the operators in Python. So I'll do another new cell and go ahead and try something like sum. We've already tried sum before. So sum is like 21 plus 22, enter. I've not written print, so I'll either have to print or, oh, and then something interesting about using the Jupyter Notebook, you don't necessarily have to type print every time you like want to print something. So you can just say sum is equals to this, then sum, and then you get the answer. And then something like, let's see, another thing we want to do is subtraction. So if I want to do, let me change this to a smaller value so that I can be able to subtract. So you want to do 21 minus 12, and then get the subtraction, it's 9. And then do something like division, which will be 21 divided by 12, enter. Oh, no, I have to write division to give me the output. So it's 1.75, and then the last one is multiplication, which is something like 21 multiplied by 12, and then the answer, again, I have to write multiplication. So to print everything here, I'll do something like print, and then in brackets, I want the sum, I want the subtraction, I want to get the division, and I also want to get the multiplication. Then I write enter. So it will give me sum is 33, subtraction is 9, division is 1.75. We multiply, I get to 52. So that's it about arithmetic operators. For assignment operators, so we say x is equals to 2. So what is x? Which is 2. And then we want to increase x plus 5. So x plus is equals to 5. It gives us 7. So 2 plus 5 is, of course, 7. And then we want to subtract x minus is equals 5. So it will give us 2. That is 2, 7, then back to 2. And then we want to do something like division. 2 divided by is equals 2. Oh, sorry, I've forgotten the x again. It will give us 1 because at this point we've reduced it to 1. And then the last thing is x multiplication by 2. So it will come back, the answer will just come back to 2. So that's it about assignment operators. So you will find scenarios where you have to like increment. For example, every time someone plays a song, that's like the playlist reduces by 1. It's like when you're on Spotify and you have your whole playlist, and it will continuously reduce by 1 every time you play a song. So once it's played, it gets out, so on and so forth. So this is like this is just assignment arithmetic operators. And then one last interesting thing is things like dates. So how do you, for example, we've talked about, we're still talking about numbers. So what is like, Python will give you a very simple way of getting the date. So the first thing is importing the libraries. So we'll talk, in Python, you'll have to work, in data science, you'll have to work with a couple of libraries like NumPy, which is numerical Python, pandas, which will help you go around your data frame, try to manipulate your data, clean and so on. And things like Matplotlib and Seaborn, which will help you visualize your data. Then scikit-learn, which will help you with machine learning. Scikit-learn, TensorFlow, Keras, which will help you with machine learning and AI. So you'll meet all these libraries from time to time. So how do you import the datetime library and then play around with it to tell you what today's date is? So I'll import from datetime. I'll import date. So, and then what we want to figure out is today's date. So I'll go to date, today, and then voila, today is the 13th day of June, which is exactly right. And then probably you want to play around with your output and do something like print, and then say today is, and then give the date. So add a date dot today, it gives you an error. Why? It tells you you can only concatenate string to string. I think you've realized up here I've been concatenating things. So like name, Bethany comes from Kenya, something of that sort. So concatenating is adding the different variables together. And you cannot concatenate different data types. You can only concatenate the same data type. So you can't go like the thing I tried here was adding a string, and of course this is technically not a specific data type. It's probably integers together. So of course it will tell me you can't concatenate them. Even if I do something like let me erase this for a minute and write 21, to still give me the same error. But if I do, and then you've talked about operations. This is technically not an operation. So if I do 21 plus 21, it won't give me 42. It will give me, oh yeah, it will give me 42 actually. But if there are strings and I add them together, if they're both strings and I add them together, they'll give me something else. They'll give me 21 plus 21. So how do we make this a string? Because I can't just go and do like, okay, I remove the date, I add two quotation marks, and then it won't give me the value I want. Of course, it will give me today's date is date dot today, but I want it to give me today's date. So how do you go about this? So you come and use we want to make it string. So you use the string function. So string, enter in brackets, date dot today, and it will give you something different. So today's date is 13th June 2022. So that's something you should be mindful of when you're printing and trying to make your data, see if there's any sense in your data. Okay, so I've taught you a bit about this. So probably you might be wondering if someone wants to use if I want to, let me use this example again. If my name is not Bethany and I want someone someone is from a different country, how do I go about it? So let's use the same code here, come down, and you want to have the person add their names automatically. So we'll use something called an input. So with input, it's just another function. So you do input into, and then probably tell the person, enter your name, and then another one, input here, and then tell the person something like enter your country. This will be very useful when you're testing the BMI. So it will come up as a pop-up in your Visual Studio Code. So you'll have to enter your name. So enter your name. My name is, let me not use my name because I've already used it. Let me use Ola's name. So the name is Ola. And then which country does he come from? That is Nigeria. And then Ola comes from Nigeria. So that's how if you want someone to now type their own input, and that will be important when we're doing the BMI, because I do not know you BMI. I want you to tell me what your BMI is. So let's go ahead and do the BMI program right now and see how it works.
Sorry,
Yeah,
Bethany, can you hear me?
yeah, I can hear you.
An awesome session. We have just one or two questions in the comment area, so I just want to call them out so that you can answer them before you move forward there. First, someone is asking, can we download Anaconda instead? You talked about Visual Studio Code and adding Python, within it, but it's asking that can we use Anaconda instead? Um, And the second question is, can you kindly teach the assignment operators again? So I believe these two
Okay.
things we need to quickly review. Thanks.
Okay, sure. So the first thing about why we're using Visual Studio Code and not Anaconda, Visual Studio Code is more dynamic compared to Anaconda. First, with Anaconda, the only thing you'll be able to do is just get your Jupyter notebook and that's it. But with Visual Studio, in case you want to create, if you now you want to output your whole code, and you're all like, once you start building the machine learning what are they called, models, and you want to export it to like another what will I call it, to use it, like create an app in the, let me start over again. So, for example, when you reach the ML side, where we're now doing our models and we want it to be consumed by someone else. So, it's very easy to create another file, not necessarily a notebook, but even Python files within Visual Studio Code, and you can still consume the code from a previous file. That's the first thing. Secondly, Visual Studio Code is very robust. So, I'll show you at the end things like source control. So, how do you go about publishing your code to GitHub? This is one of the easiest. This is one of the easiest parts. Like if you want to like publish your code, this is one of the easiest thing you can do. Of course, there are very many extensions. We'll do a bit on Azure at the end. So also I'll teach you how you can work directly from your PC, go ahead and deploy your Azure models and so on. Yeah, so that's the main reason why we're using Visual Studio Code. And then operators. So let me go back to that slide. So operators just assign values to something. So for example, the example I did was the example I did was x is equals to 2. And then what is x? So it will just tell me x is equals to 2. But then if I add, this is incrementing x by 2. So already we have x is equals to 2, increment. So if I continue, it will continue increasing. If I do something like now decrease x, so it will be back to 18. If I want to multiply it, it is just like x multiplied. So now the value of x is 36, and I want to divide 36 by 2. So instead of you going and doing x is equals to x divided by 2, you can just remove all this and have the division here. And we go back to 9. So that's it about the assignment operators. So it helps you to either increment, decrease, or multiply without writing the whole thing like x is equals to x plus 2. No, you already have x. So x plus is equals to 2. So it will do the original value, then plus 2. And then I've also seen someone is asking, I've also seen
Yeah.
someone is asking the aspect of inputs. So let's go
Yeah.
back to that again. So as I mentioned, as I mentioned, I already printed my name here. So these are variables. So I assigned my name Bethany, my country Kenya. Then once I printed it, it just came automatically. Bethany comes from Kenya. But then what if I want the user to add their own values? We'll have to, I do not know probably the BMI of Ola by just looking at him. And to be able to calculate it, I'll need his height and his weight. I do not know that offhand. So I'll probably have to ask him to fill in. So instead of now just coming and changing it over and over again, if you have multiple users, use input. So with input, you can now tell the user, enter your name, enter your country, and then print, he comes from Nigeria. Let's say, for example, let me see. So the person who asked the name was Jimo. Oh no, the person who asked was Dorcas Ayelagbe. So let me see, probably your name is Dorcas. Dorcas And then country, because I know this program is open to only Nigerians. I believe you're from Nigeria. So, and then Dorcas comes from Nigeria. That's the value. That's how now you do the inputs and bring out an output. So that's how inputs work. You are trying to compare Vision and Anaconda. Could you come back again? Maybe I can pass this to Ola. Ola, you're also a data scientist, so why should we use Visual Studio Code instead of Anaconda?
Thank you. I mean, Bethany, for the question. Like you rightly said the other time, Visual Studio Code is more robust and extensible than Anaconda. For example, Anaconda has two major flavor of applications that you can use within it. One of it is Python or R. So, number one, what if you are writing outside these two languages? Where will you go to? Within Visual Studio Code, you can write virtually different programming languages. And number two, when it comes to model deployment, which she talks about, when you are done building your code in Jupyter Notebook, how about deploying this code? You don't leave it in a notebook. You need to wrap it up in the framework like Flask, like Streamlit, and the rest, which
Django,
literally
yeah.
requires you to write some code, which is different from notebook codes. So Visual Studio Code makes it easier to deploy your model. Connecting to Microsoft Azure, you can do that connection right inside Visual Studio Code. As you can see, there is this icon by the left hand side that shows that yes, you can connect directly to Azure. Code management in terms of repository, she talks about GitHub. Your work, version control, you can do that straight within Visual Studio Code. So this alone sort of explain a lot of differences why you should go with Visual Studio Code over Jupyter Notebook within Anaconda. I hope that sort of clarifies this.
Yeah, I hope that also clarifies it. Yeah, I can see Josiah saying thank you. Adorcas also saying thank you. Tijani also saying thank you. So yeah, I hope that answers most of the questions. So my session is not that lengthy. It's just that so if you have like any question, just be sure to post it down. So yeah, we're now creating our BMI calculator. So uh, yeah, so probably the first thing is I want people to know what this is. So I'll print and then write something like, this is a BMI calculator. And then since I want people to input their own weights and heights, I'll do an input value here. So weight is equals to input, and then we are using weight in kilograms. So enter your weight in kilograms, and then we're doing height in meters. So height is equals to input. Oops, sorry, input. Oh, so probably you might be asking, how do you move like from this to now like having the input? And most of the time you can see I'm not coming here to point it back. So for example, I'll do this, then using the down arrow and tab, and it will come along. So I hope you're not wondering how that's happening. And then enter your height. So we want height in meters, And then how does the BMI calculator works? So it will first print, and then so this is the output. So our thinking is we have the weight. So weight is of course in integers. So integer, and then so as you can see here, this is a string. So probably if they do an input, it will be a string, but we want to convert it to an integer. So it will be integer and then weight, and then we divide it by the now height multiplied by 2. So that's how the BMI calculator works. Weight over your height times 2. So divide it by integer, and then height multiplied by integer, then height. Oh, sorry, height. And then let's see what we'll get. So control enter. And then enter your weight in kilograms. So let's say assume I am about 50 kgs, and then enter your height in meters. So I'm about 5 foot, so that's about 150-ish. So 150 into meters, that's 150 centimeters into meters, it's about 1.5. And what is it giving me? It's giving me an error, telling me the integer cannot have this space. So as I said, integers are just numbers. But then if you want this, you'll have to convert it to a float. So of course, let me change this to float. So float, and then this to float. And then I run again. I see it will solve that. So I said I'm 50, and then my height is about 1.5, giving me a BMI of 50. That's very high. Okay. And then the other thing you should know is, yes, I've gotten the BMI of 50, but then probably someone is 50.5 kgs. How do I do that? I'll have to convert this to float. But you see, at the end of the day, you're doing too much as a print that at some point you're losing count of what's happening. So instead of coming and adding all this at the end, you can do this before while you're doing the input. So once someone inputs something, it gets directly translated to a different data type. So float, and then the data type, also float again, and then the data type, float, and then data type. So I'll erase a lot of this. So you can see it saves me a lot of, it reduces a lot of this text that I had here. So remove the float again, instead of coming back and repeating myself over and over again. And then, yeah, how else can we make this a bit better? So probably we can go ahead and instead of doing all this at the print, we can create a new variable called the BMI and call it the calculation of the BMI, which is weight divided by height multiplied by height. So I can do height squared or something of that sort. No, I can't. I'll have to go and multiply by height. And then the only thing I'll be printing here is BMI. So with this, by reducing your values in the print, if there's any error that happens, you'll be able to detect it very fast. So if, for example, I omitted this bracket and it was a print, and the print had all those values inside it, there's a very high chance I might miss like where the error is. But if you break down your work into different chunkable parts, you can be able to tell apart everything. So let's go back again and do my BMI. So we said 50 and then probably 1.5. My BMI is 22.22. This now makes better sense. And then we come back and do something else. So the last part is, I've already calculated my BMI, but I'm not sure whether I'm overweight, underweight, or I'm healthy. So how do we do this? So I'll introduce a snippet of something called logic. These are conditions. So how do you, let me see if I had a slide on this. Yes, these are conditions. So how do you tell someone if your weight is equals to this, that you're underweight? So these are conditions that we use. So there's a meme of a programmer chatting with another person. And then the person asks, okay, I love you. Do you love me? And then the guy says, yes, something like, yes, I love you. And then the operator in here is this. So so you can write your name. This one loves you, but then this one it says it's not equal to. So meaning A and B are not supposed to be equal. So if someone tells you that, it means they're just lying to you in a programmatic way, right? So you should be able to understand what each of these things mean, each of these operators mean. I'll just say conditional logics. So the first one is A is equals to B. So if A double equals B, it means A is exactly the same as B. If A then exclamation equals to, it means A is not equal to B. Then the same for the rest. I think you all passed through a maths class at some point. So all this is less than or equal to, greater than or equal to. So you probably have an idea of what all of them mean. So let me go back to my code and do a bit of conditions. Yeah, here we are. So probably I can say overweight. We are overweight. It's probably a BMI of what is the overweight BMI? It's about greater than 30. So if your BMI is greater than 30, you're overweight. But let me not push it far a lot. Let me just do something like, let me first do a smaller introduction, because if I dive into the deeper side, you might get lost. So let's do something simple like A and B. So let's give A the value of 23 and B the value of 12. And then let's check. So how do you now check if these are equal or not? So we use something called if, else, elif statements. So if statements tell you, like, if A is equals to B, print B. If A is not equal to B, so on, so on and so forth. So if we do a simple if you'll just do an expression to test. It's like testing. So if A is greater than B, then these are colons. Do not forget those two. And then print B. And it tells you 12. So if A is greater than B, print B. Is A greater than B? Yes. So we're printing 12. Okay, that's right. So if I do the opposite, I do not expect any output. But then what if you want them to give you different outputs? So that's where else comes in. Python is big on indentation. So else you don't indent it inwards, you go back and you use else here, and of course the colons must be there. And then if that's not the answer, then print A is greater than B. You see, you've now like given different alternatives what to print. So yes, if I'm not underweight, I'm probably overweight or something of that sort. So how do you do this? So the other thing is, what if we add another variable? No, not even adding another variable. What if A and B are equal? What do we do then? So it will tell me A is greater than B. Why? That's an error. But anyway, they're the same. So I'm not expecting to get an answer like that. If I'm getting this, it means there's of course an error. So how do you tackle this? So you can add another statement called an elif. So elif is written that way, and then you have to state. So if A is equals to B, print something else. So print something like A and B are equal. Because at the end of the day, if I don't write this, if A and B are equal, you see the answer it's giving me, it's telling me is greater than B, which is a lie. So let's see if this will work. Control Enter, A and B are equal. If I change this to 13, is greater than B. If I change this to 15, it gives me 15 as the output. So probably don't want to write 15 here as the output. You want to write something like A is less than B. Voila. So it gives you different outputs depending on the conditions that you put in there. Okay, so you can have as many things inside and outside. So there's one last thing that will be very useful when we are doing our next part, that is the nested statements, nested conditions. So if I had another function C and it's like 10, how do I go about this? So I'll have to add another code inside here. So of course I have the A, B and stuff and everything, but then how do I factor in C? So that's where you do an nested if statement. So I'll come here, do another if statement. So if A, let me change this to greater than. Then I come back to if B is greater than C. What do I see? So I'll print something like A is greater than B and B is greater than C. So let's see. Oh, wait, what? Oh, this is this is interesting. As A is equals to B. So, or else, let me see. Else, I'm wondering why it's giving me this value. Print A is if it's not, so A is less than B. I'm now confused. Sorry, give me a second. So as you can see, A is of course greater than B, and B is greater than C, meaning this is what was supposed to be printed. Give me a second. Oh, now I see. Nope, I still don't see it. So I comment out this last part. Oh, sorry. A is greater than B. So if A is greater than B, and if B is greater than C, A is greater than B and B is greater than C. Okay, let me do an else here. Backspace else print A is greater than B, B is greater than A is greater than A is greater than B. Oh, I'm seeing the issue. A is not greater than B. That's why it skipped to the last one. Okay, I think I wasn't reading the logic well. I was seeing this as 16. So if A is greater than B, the logic is okay. So if A is greater than B, which it's not, so I won't go to this. I'll go directly to the else. The else if or else. I won't even check to see what this is here. So that's why it's printing directly that A is greater than B. But then you see that that's technically not right, because there's some things I'm missing. For example, at this point, oh no, it's me who's printed the wrong thing. So at this point, I'll have to write A is less than B. So nesting, I'm so sorry for the small confusion. I literally thought I saw this was higher than the others. So if I had this as a 16 and I print, it will give me this: A is greater than B and B is greater than C. But then if B is not greater than C, which is, let me put this as 16, put this as 18, it will have to print this part. So it will say A is greater than B. So of course, A will be greater than B, okay, but then B would be greater than C. So B is less than C. Let's run and see. It will give me that. So it's a bit confusing because you're doing just numbers and they're all different. But then that's how the if and else and elif work. So let's go back to our BMI. I won't type this. I'll just copy paste the code because we are 4 minutes away from time. And I want to also show you how you can post your code on GitHub. But then I hope you've understood the condition. So if it meets this condition, it will go to here. If it doesn't meet this condition, it will go directly to elif. And then if it doesn't meet that, it will go directly to else. Okay. So for our BMI calculator, we want to, let's go back to our code here. We're good with this code, so we can copy this code. And then we also want to add like the values. So is this person overweight, is this person underweight, and so on. So we'll have to add another part at the end, which is now if-else statements. So it will be an if, and the biggest condition we have is the BMI should be more than 0. If your BMI is less than 0, you're lying to us. So your details are probably wrong. So this will be the final code to create the BMI. And if I run it, let me run this cell, enter my weight in kgs, we go back to 50, then height 1.5, and the output will tell me, hey, you're healthy, because I am greater than 18, but wait, so if BMI is less than 18, so I'm greater than 18, which means I'm healthy. I'm less than 25, but greater than 18. So that means I'm healthy. So that's the code that we have. So the first thing is validating if the user actually put the right numbers, because you can't have your BMI as 0 at any point if you put the right values. And then now continuing on and now giving the if else. So if your BMI is less than 16, you're underweight, and so on. Okay, so I think we've talked a lot about Python, and this gives you a start to continue with the next modules and so on and so on. But before I go, I want you to be able to probably share with the world what you worked on. So if you come back, if you've not been following through and you'll follow later on, this is a very important step I'll want you to do. So you go directly to Visual Studio Code and just go to publish to GitHub. So I want it as so depending on if you want to share with the rest of the world, publish it as public. If you do not want, you can just do a private repository. So publish a private repository for me. And yeah, I want all the files to be included, publishing to GitHub. Okay, and then I come to my terminal, go to terminal, and then you can probably change your terminal type to something like Git bash. But with PowerShell, I can pretty much do the same thing. But I'll come here and now state git, add everything I have locally, then I commit. So git add, this is git add all. So adding all the files I already have locally. And then git commit is now scheduling your code to go to GitHub, like just staging it, but you've not pushed the code there. You're just telling it, okay, this is code that's supposed to go there. A git commit must also have a message like my first, my first Python program. And then it will tell me things like, oh, an error, but it's already committed. So if I want, I'll just go ahead and publish the branch. I can either do that here or here. Go ahead and publish. So the branch that I'm working on, publish it as to my private repository. No, why is it giving me an error? So let me do git push. I see what the error is. Git push. Git push. Master. Master does not appear to be a GitHub repository. And this is interesting. So nope. There are no changes. So the only problem that might be here is I'll have to git pull my work, git pull remote branch. So git pull, then let me open my repository that I've just created.
I was about to say the same thing, but can you check the repo itself?
Yes, that's what I'm looking at. So I'll go to github.com/Bethany Jep, and then the repositories. So the repository is already created. But then what's the error? So commit, my first commit, the branch. But then what error did it give me locally? Commit. Oh, your name and email address. Please check that they're accurate. Run the following commands to follow instructions. Oh, I have to update my my details. Considering I'm using, let me see. Considering I'm using a different, probably a different email on this PC. Okay. So Bethany, yeah, I'm using a different email, so I have to edit. But I don't want to. I just want. It's okay for me. But let me just update my email here. Nancy, so please. Okay. So I'm not sure why I have this configuration. It's probably because I'm using a different email from my personal one. So, but it's supposed to push directly. So once you do your commits and everything, it's supposed to push your repository directly to your GitHub. So I'll figure this problem out, and probably at the end of the day, I'll have typed and shared with you the error. But since we are out of time, I'll just go ahead and share with you the resources we're using for this session. So if you can take a screenshot for this and have it somewhere in your bag or something in your PC to always refer to it. So these are the curriculums we'll be using. The first one is Python for Beginners, which is aka.ms/py for beginners. Then we have data science and machine learning for beginners. So for data science, it's aka.ms/ds for beginners. For machine learning, is aka.ms/ml for beginners. And then, of course, if you want to learn more about GitHub and Azure and why exactly I have this problem, there's always a student hub at aka.ms/learnstudent. It will give you instructions as to why exactly probably my code failed and so on. But you'll be able to figure out your way around GitHub, your way around Python, and everything. But for today and tomorrow, I want you to solidify your knowledge on Python. I want you to understand like what different things you can do with Python, because from Wednesday we'll be diving into now the different Python libraries we are supposed to use for data science and machine learning. So I'll share the resources, I'll ensure the resources I shared with you, but I think unless Ola has any questions or anything else to add.
Right. Thank you very much, Bethany. It's been a really engaging and interesting session. It's good to go through from known to known. I want to appreciate you for the time. So, what I would rather say is that please take note of these resources. We're still going to share them with you on the Discord channel. And if you are joining us and you are wondering, oh, how do I join? How do I participate in the conversation and have access to other sessions from the Discord channel? Please, we're going to drop the registration link in the comment area so that you can actually register for the ongoing learning. It's going to last for 30 days and we are documenting every session so you'll be able to partake and participate. Okay, so don't forget to practice these as well and share your knowledge, what you have gained today, share it on social media, on Twitter, on LinkedIn, using the hashtag NG 30 Days of Learning. Let the conversation continue on Discord. Our mentors, our subject matter experts are there to help you and clarify what question you will be having based on this session. And thank you because we've come to the end of today's class.
Yeah, but before we go, I'm not sure if I've fixed, but let me check if it's fixed. Let me refresh and see if I've fixed it. Oh, not yet. Okay, I'll just share the fix once I'm able to find it. But otherwise, have a good rest of your day.